In this tutorial I'm going to go over Section 1, which contains general information for the Pilot's Operating Handbook on the Cessna 172S. Like the start of any section, we've got the table of contents which itemizes all the information to come. If we go to the next page, we can see it's blank, and normally they would say that this page is intentionally left blank. For some reason it's not included here in this PDF document. Next we've got the 3-view drawing of the aircraft and some important footnotes on items like the wing area, ground clearance of the propeller, wheelbase, etc. Here we've got introduction, which basically gives an overview that the POH is going to contain 9 sections, and that the section 1 is going to have definitions, explanation of symbols, abbreviations, and terminology that will be commonly used throughout the rest of this Pilot's Operating Handbook. We can start with the engine, and it tells us that we've got obviously one engine. It's an IO 360 L2A, and it's 360 cubic inches, hence the 360. Normally aspirated, direct drive, which means the propeller bolts right onto the drive shaft of the engine. It's air-cooled, which is why we have those air intakes on the front cowling, horizontally opposed so that the cylinders lie flat and opposite from each other. Fuel injected, and 4 cylinders. Horsepower rating and engine speed is 180 brake horsepower at 2,700 RPM, and that's based at sea level. Here we have information on the propeller, and number of blades are 2, and it's fixed pitch. Here we've got information on the fuel system, and it says use of unapproved fuels may result in damage to the engine and fuel system components, resulting in possible engine failure. So what you can use is 100 low lead, which is blue, and 100, which is green. And then here's a little note if you want to put additives in fuel, and then also the fuel capacity, which is 56 gallons total. 53 of those are usable, and 28 per tank, 26.5 gallons per tank usable. And a note here that when you're fueling, to get maximum fuel capacity and to minimize cross-feeding when you're refueling, always park the airplane wings level with a normal ground attitude so that the nose of the aircraft is not pointed too high or too low, and place the fuel selector valve in the left or right position, not both, and that will allow for optimal refueling of the aircraft. Here we can see information on oil specifications, what you should do when the aircraft is first delivered for the first 25 hours. You put a different grade of oil, then you switch over to your standard oil after that. And here it tells you after 50 hours of oil consumption has stabilized. Here we have information on the viscosity for various temperatures that the engine might be operating at. Here we can see that the oil capacity at the sump is 8 US quarts, and the total is 9 US quarts. If we go here, we can see the certified weights, 2,558 pounds in the normal and 2,208 in the utility category. And then it tells us our takeoff and landing weights, and you'll see that there's no difference, which basically means you can take off and land the aircraft at maximum gross weight if you wanted to. Some airplanes, like a large airliner, can't do that, and you have to dump the fuel before you can land if you have to go around for an emergency. But for the small general aviation airplane of a Cessna 172, not an issue. Here we can see weight in the baggage compartments, 120 for Station A and 50 pounds for Station B. However, the combined weight of Station A and Station B cannot exceed 120 pounds. And then there's a note here that says weight in baggage compartment for the utility category. In this category, the rear seat must not be occupied and the baggage compartment must be empty. Here we can see standard empty weights, which is 1,663 pounds. That means that it's everything in the aircraft that's basic to the airplane. So no baggage, no people, but it does have all the installed avionics. It has the unusable fuel, the unusable oil. It's got, all the things that would go in the airplane, the tow bar. So these are the things that you don't change from flight to flight. The things that you would change from flight to flight would be the baggage and the people and the number of gallons of fuel that you would put into the aircraft that are actually usable. Here we can see the useful load, or how much stuff we can put in there that I just described, which is 895 pounds normal and 545 pounds utility. Here it tells us notes on the baggage space and entry dimensions, and then it tells us here the wing and power loading, which is 14.7 pounds per square feet, and the power loading is 14.2 pounds per horsepower. Here we've got where we define our terminology. For example, VNO, maximum structural cruising speed, speed at which should not be exceeded except in smooth air, then only with caution. And the list goes on. Here we've got outside air temperature. This is an important one. It's standard temperature, because you might have a hard time finding that if you look at the performance section of the POH and you wonder, well, what's standard temperature? I can't find it anywhere. It's defined here, and it's 15 degrees Celsius at sea level, pressure and altitude, and decreases 2 degrees Celsius for each 1,000 feet. That's known as the lapse rate. It lapses 2 degrees per 1,000 feet. And here the pressure altitude, which is 290.902 for standard conditions. Here we've got information on engine power terminology. Here we've got more closed throttle, full throttle, etc. Here we've got information for performance and flight planning, usable fuel, and then we've got unusable fuel, which I talked about earlier, gallons per hour, etc. Here we've got weight and balance terminology. Standard empty weight is the weight of a standard airplane, including unusable fuel, full of operating fluids and engine oil. So that's the exact precise definition of what standard empty weight was earlier. Here we've got weight and balance terminology continued. Here we've got now conversions information. So here we've got from kilograms to pounds, pounds to kilograms, and it's a lookup table. Here we've got weight conversions from pounds to kilograms, length conversions from meters to feet and feet to meters, and then another scale version of that. Length conversion, centimeters to inches, inches to centimeters, and another scale. Distance conversions, volume conversions, temperature conversions, pressure conversions, volume to weight conversions, and then this kind of quick conversion. I understand what's going on here because I have an engineering background. If you don't have an engineering background, this chart can be kind of confusing, to be honest. Even with an engineering background, it's a bit much. I would generally not run to this chart for the first thing. There's better ways to do it. They're just trying to show you kind of a flow chart of the different possible combinations and ways you could do it. But honestly, there's no reason why you can't use your E6B to do the vast majority of these calculations. And if you're doing pre-flight, you're not doing this in the air, just go to Google and you can actually Google the conversion, and you can say 3 gallons of fuel to pounds. It might not work for gallons of fuel, but you could do conversions for other things like centimeters to feet, etc. And after that we go on to section 2. So that's the conclusion of section 1, and it's really that simple.